Hello everyone. For the rest of today's lecture, we'll be going through a really long demo problem which contains three different stages. I have already created a template notebook file for you. Go ahead and download the template notebook file. If you want to get hands-on experience, you can skip watching the rest of the lectures for today. Instead, you can try to solve the demo problem on your own. I've given detailed pseudocode steps for each of the stages for you to go through. You already know everything that you need in order to solve this particular demo problem. You know how to use the request module to send HTTP GET requests. You also know what functions you need inside the Beautiful Soup module in order to parse various HTML file formats. Let me go through stage number 1 here. In stage number 1, we are going to be working with this Wikipedia page which lists all the US states. Let me show you that Wikipedia page. On this Wikipedia page, we have this really large table which contains the list of US states. Each state has its own link. For example, I can open the link for the state of Alabama, which in turn contains the information about the state of Alabama, including the capital and other associated details. In stage 1, we are going to be parsing the Wikipedia URL for the list of states, and we want to be able to retrieve the URL for each of the individual states that are listed in the really large table. Stage 2 is going to take all the URLs that we parsed as part of stage 1, and it's going to download each of the states' HTML files. After stage 2, we are going to have 50 HTML files to represent the 50 US states. In stage 3, we are going to parse the individual states' HTML file format, and we are going to retrieve this table information in the form of a Python dictionary. Once we retrieve all of the state information in the form of individual dictionaries, we are then going to create a dictionary which contains all of those dictionaries. It's very easy for us to convert a dictionary of dictionaries into pandas data frame in order to be able to process and analyze the data. Let me switch over to my Jupyter notebook over here. I'm first going to do all the required imports. So I just need to import requests, which we are going to use to send HTTP GET requests. And we need to import Beautiful Soup, and I'm going to say from BS4 import Beautiful Soup. And I'm also going to import pandas as PD. I'm also going to be needing the OS module because we are going to do a lot of file processing. So I'm going to import that in advance. The Beautiful Soup module enables us to parse HTML file content. Right, stage 1 is about extracting all of the state URLs from that really large table. I'm first going to send a HTTP GET request to the Wikipedia URL, which is mentioned here in the list of instructions in the pseudocode for you. Recall that you can just say request.get of URL, and I'm going to capture the response into a variable called R. Again, I'm using a short variable name just because I'm going through a live demo over here. Always we want to raise for status. Recall that that just asserts that the status code is 200 OK. Let me go ahead and run that. Right, I am going to actually do a kernel restart and clear all output just so that I can feel assured that I don't have any stale content here. All right, I am going to go ahead and print r.txt. That's the content of the HTML page that we are retrieving when we send a GET request to this particular URL over here. Notice that we have a lot of cluttered information. In this information, we need to find whatever we are looking for. Right, let's check out type of r.text. So you're going to always get a string type whenever you access r.text unless you explicitly used r.json function in order to convert the content into JSON format. Since we are dealing with HTML format here, we are just going to deal with the string version of the response content over here. Right, the next step says create beautiful soup object. Recall that you need to do that by saying beautiful soup, and you have two arguments. The first one is going to be the HTML, and the next one is going to be just the string called html.parser, right? Where is the HTML coming from? It's coming from r.txt. We just sent a HTTP GET request for that. So I'm going to say r.txt as the first argument, and let me capture the return value into a variable called dog. Let's try to prettify the HTML format over here, and I'm going to print whatever we are getting as part of the prettify function. It still looks really ugly, and you have a lot of information over here, much better than what you had before, because you're now able to see the table like a table inside your HTML file format over here. Right, the next step is actually not a coding step. I want you to understand how you can use developer tools on Google Chrome. Let me go back to the list of state URL page over here. Let's say that I want to inspect this particular element inside my HTML file over here. I can do that by right clicking on that and clicking on inspect, and that should open what is called as developer tools for you. So you have a lot of information here. Let me just try and walk through some of it for you. So we have this really large table in the web page, which is given by the Wikipedia list of US states URL. Notice that we are right now trying to access information about the Hawaii entry. I should say Hawaii, right? Sorry, Hawaii entry inside the table, which is present inside what is called as th. We didn't quite talk about th tag. Th represents table header, which gives you some information about that particular row. Th is part of the tr tag. Recall that tr tag enables us to represent each row. And inside each tr tag, you're going to have td, which represents table data, which refers to a single cell. And your tr tag is typically within a table tag. This is a very useful tool for you to explore and poke around the HTML file format. All right, let me go back to my Jupyter notebook. We are going to try to use the beautiful soup object that we just created, which is called as doc, and we are going to call the FindAll functions in order to first of all find the really large table. Let me go ahead and call the FindAll function by passing table as an argument. Notice that we have to pass the name of the tag as a string argument to the FindAll function. This is going to return all the table tags for me. So I'm going to capture the return value into a variable called tables. And let me print the length of tables because it's supposed to give me a list of tags. So since we are using find_all function, we are trying to retrieve all the tables on the Wikipedia page for list of US states. Let me also go ahead and print type of tables. Right, looks like we only have one table, so that's a good thing. The type of tables is showing up as beautiful soup element, so that's a kind of element tag within your DOM tree. The next thing which I want to be able to do is, I want to be able to ensure that if at all somebody decides to add a new table to this particular web page for the list of US states, I want my code to be still able to work. I want my code to throw an error if something has changed with the URL, not URL, sorry, the web page itself. So I'm going to go ahead and assert that len of tables should be exactly 1. So I don't want the rest of my code to fail if the web page format has changed. Right now, nothing is going to happen when we run this assert because we are just doing a futuristic assert over here. Sorry, futuristic, got it. All right, I am going to retrieve the first table into a variable called tbl, and I can do that by saying table of 0. So we have a list of BS4 elements, so I can retrieve the first element into the variable called tbl. And I'm going to go ahead and print type of tbl over here. Sorry, there we go. All right, I should be using the variable name tables, fix that. All right, notice that, oh, I printed table instead of type of table. Excuse me. Let me go ahead and print type of table instead. All right. When we access individual entries in the list of elements, we are getting the element tag for that particular table. So that's what we are interested in, right? We want to be able to retrieve all the URLs for individual states, which is part of this particular table. So we are finally able to retrieve the table tag over here. So let me go ahead and display the contents of table. Notice that we are getting all the table entries, which include the table header, and the associated table rows can be found somewhere in this text over here. All right, let's continue with stage 1. We have found the table that we are looking for. Inside the table, we want to be able to find all the table row entries, right? Because we want to get the URL associated with the table row entry over here. So the next thing which I'm going to do is I'm going to search for all the tr tags, and instead of saying doc.findAll of tr, I'm going to now say tbl.find underscore all of tr, so that we can search inside the table tag element that we just found. So I'm going to save the result into a variable called trs. Let me go ahead and print len of trs and also print type of trs here. We're just trying to poke around and explore various elements that we run into as part of our processing of this list of US states page over here. Right, looks like we have 52 rows. We might have some additional rows other than the actual US states. And when we look at the type of TRs, we are getting what is called as beautiful soup for element type, which is of a result set over here. One thing which you can assert here to make sure that you're accessing the right table one more time is that you can try to assert that length of TRs here is greater than or equal to 50. So let me go ahead and do that. I'm going to say len of TRs is greater than or equal to 50. Again, this is also a futuristic assert. We're going to be able to pass this assert right now because clearly the length of TRs is 52. The next step is going to be really complex and lengthy. I have provided detailed steps for you here. Let me go through each part of it over here. So we have retrieved all the table rows in the really big table. Now we want to be able to retrieve each of the URLs within the anchor tags inside the TR entries over here. So that's what we are going to do next. Let me go ahead and follow the steps over here. So I am going to iterate over each item in TRs, and I'm going to say for TR in TRs, and I'm just going to print TR for starters. Alright, we are getting all the table rows over here. Inside the table rows, we want to be able to find the table header value which contains the name of that particular state. So if you go back to the developer tools and explore a little bit more, you can identify that th is the correct tag that we are looking for here. So I can find the th tag inside each table row by saying tr.find of th. Each table row is going to contain only one th tag, so I can just use the find function over here. I'm going to capture the return value into a th variable. Let me go ahead and print th, and I'm also going to print type of th. Right, looks like we are getting the table header value here, and we are getting that as a BS4 element tag, so that's a good sign. The next thing which I want to do is, I want to be able to retrieve the anchor link inside each table header. So I'm going to do that by finding all the anchor links. So I'll tell you why we are using the FindAll method here shortly. And I'm going to call the variable that's going to store this information as links. Let me go ahead and print length of links here. Notice that some of the print function call here prints two links instead of one links. Let me go ahead and print the th tags text over here, and I'm going to do that by saying th.get underscore text, and let's try and see which particular states over here have two links. Looks like Kentucky has two links. Let's go and search Kentucky in this list. Notice that you have this extra citation that is included as part of the Kentucky entry in the table. What we are interested in is just the first link over here and not the second link. So let me just go ahead and confirm that we only want to retrieve the first link. Also, there are entries in the table which have zero links. Here is an example for you. You want to be able to skip over those links. So that's what I'm going to do next. I am going to check that len of links is equal to 0. If so, then I just want to continue and skip over that link. If that is not the case, I want to retrieve the first link by saying links of 0. Let me go ahead and print link over here. Right, looks like we are getting all the anchor tags over here, so that's a good sign. What we actually want is the href information inside the anchor tag. Let me show you the output that we get when we print both the attribute and the text associated with the link over here. Instead of printing link, I'm going to say link dot get underscore text, and I'm also going to say link dot attr's. Right, notice that the text part of it gives the name of the state, and the attributes gives you a dictionary where href is the key and your value is the URL. What we actually need is the entire URL, correct? So let's go ahead and define a prefix part over here. And I'm going to have to define that outside my for loop because we need the same prefix for all the state files, right? I've given you the prefix URL part in the list of pseudocode steps. I am also going to be capturing each state's URL into a dictionary. So I'm going to define a state underscore links dictionary up here. My key is going to be state name and my value is going to be state URL. This is my giving my state name. Inside link attributes dictionary, the href key gives me the URL part. So I'm going to go ahead and populate that inside my dictionary. So I'm going to say state equal to link dot get underscore text, and then I'm going to say state underscore URL equal to link dot attr's of href because that's a dictionary. I can access the key. And I also want to be able to concatenate the prefix with that particular URL part over here. Then I'm finally going to say state underscore links of state equal to state underscore URL, because I want to add the key value pair where key is the name of the state and the value is the URL for the state inside my state links dictionary over here. Let me go ahead and display state underscore links dictionary. Right, looks like we are all set here for stage 1 because that's what we wanted to achieve here. We want to retrieve all the URLs for each of the state pages. I'll wrap up this video here. We'll go through stage 2 in the next video.